can get going. It's about time, so thank you very much for being here. So today I wanted to talk a little bit about GitOps and then Jenkins X, and then I'm gonna make a fool of myself by talking about the future of CI/CD. So anyhow, so I know you guys all practice software development, and as part of the Cloudbees team, what I see everywhere is that the organizations, enterprises everywhere, trying to get better at software delivery. Right? It's sort of like one person said it very well. Like a grass is brown everywhere. Like everyone is suffering how to do software. And then what's kind of even more depressing, actually, on that note. So there's this very influential reports that's done by DORA, a DevOps Research Institute, I think, but maybe it doesn't stand for something else. Anyhow, so this team does a very rigorous scientific study on how the organizations do software development and what makes them work and what breaks them. And then one of the notes that they discover is that the companies who are good at those seems to be getting better, and then the company who suck at them isn't getting any better at all. So that's kind of an even more depressing note. But perhaps that adds more urgency to those of us who are trying to get ahead of the game. So so I've been preaching this CI/CD for, I guess, at this point, 15 years now. I think one of the things that is kind of difficult to wrap their heads around for people struggling this is, on one hand, we want to improve the throughput, meaning we want to have new features delivered faster. At the same time, we also want to maintain the stability, meaning we want to produce high-quality software. I mean, when we talk about people, when we talk about the CI and CD to people who are really behind the curve, these people generally see those two things as a conflicting factor. And then therefore, when we tell them that, look, the release that you've been doing every month, now we have to do it every day, then they mentally picture, well, I can't, that's just impossible. The test, if you just think about the test that we are running, it's going to take 3 days. So there's no way to deliver that every day. So what people, I think, fail to realize is that those two factors are not actually mutually exclusive, but they are actually one and the same thing almost. So anyhow, because I think everyone is trying to get better at the software development, the industry is trying to kind of raise the sea level, right? So unless you've been hiding under rocks, certainly in this conference, a lot of people are talking about the Kubernetes. There's a lot to like about it here. For example, the fact that it's a de facto portability layer across all sorts of different cloud platforms, so it prevents a vendor lock-in. And then obviously there's all sorts of useful functionalities like a cluster scheduling, service discovery, load balancing, et cetera, et cetera. And then perhaps something that's really close to my heart is, Kubernetes itself is an extensible platform. So being a Jenkins guy who really passionately believes about extensibility, it's great that anyone in the ecosystem can add useful pieces on top of the Kubernetes and make it a bigger, collectively create a bigger useful platform, like you can see in Knative. I think it's, this is no wonder it's getting such attraction. But anyhow, the reason I brought up Kubernetes is not because I'm a Kubernetes fanboy, but I'm trying to, but because in the face of these, a raising level of abstractions and the middleware and then the lower level platforms that make software developer productive, what I see everywhere happening is people, by which I mean release engineers and developer productivity people, are trying to rebuild their own new DevOps flow by leveraging these technologies, right? So, if you add the Kubernetes to the mix, okay, now you have to build the containers and you have to package those and you have to figure out how to deploy them. And there's this notion of environments that we are used to doing. So, how do they map in this new world of Kubernetes? Some of these higher level concepts that we've been familiar with needs to be kind of remapped and rebuilt. So I see a lot of people trying to basically stitch together the CI/CD process built around this new reality that's happening in the technology. But it's kind of a problem at the same time. And then this, I think, is something that the seasoned Jenkins users should understand all the time. As soon as you build your own way of doing CI/CD, the moment you build it, it becomes a legacy. Like, it's really hard to get your hands away from stuff that you handcrafted. And then, it's building it is hard enough. If you think about the maintenance work that has to happen afterward, and educations and keeping up to date, all of that adds up to a lot of work. So in some sense, what I like to challenge is like, you don't want to be, you want to be thinking twice before you invest yourself in this stitching together your custom CI/CD DevOps process, right? So is that the worst thing is that the important things you should be thinking about and spending time on? So if that's not the important thing, well, what is the important thing, right? So, and then if you ask me, I think that is the right user experience for the DevOps process, or the developer experience for the DevOps process. So that, if you think about that, I think the industry has pretty clearly consolidated around the notion of GitOps, right? So the GitOps, what is it, right? The general idea is you want to capture the state of the system as a sort of like a text file or something like that in the Git repository. And then you apply the same version control practices on top of it, right? So you make changes by creating a commit. You can review those by the code reviews. You can use multiple branches and so on and so forth. So bringing the same toolkit and the workflow that your team used to managing the entire state of the application in the system, not just a particular source code of the application, the configuration files. So why do people care about that, right? I think it's worth recapping. So I think one of the really useful thing, especially in the context of enterprise, is that the GitOps brings the transparency without sacrificing the auditability and access control. So what I mean by that is, even the junior people who do not have access to, let's say, commit new changes, they can still see all the changes that's been made in the past, or in places where, they say for the segregation of duties, one team gets to make a change and the other team gets to approve those. You don't have to hide the things from people who don't have access. And then so you can see the entire trace of who did what, when, for what reasons. It's entirely visible. And then whereas people used to use things like a ServiceNow ticket to file deployments, you can now replace that with more familiar the GitHub code review flow and so on and so forth. So that I think I've seen in some places it's used to achieve it used to meet the audit requirements by auditors around these notions, and then so that's kind of a modern. I see it as a modern way of meeting the compliance without getting slowed down. And two, GitOps is tool agnostic. So I mean, this is really certainly not a new concept, right? People using back in the days of Chef and Puppet and all, now to the Terraform and CloudFormation, and all these different technology that's like a convergence-based can be used in conjunction with the GitOps as a practice. So that makes us certainly very widely applicable in many different domains. And then three, it promotes higher level of abstraction and reuse because these text files can be manipulated and transformed and analyzed and so on and so forth. So often, if you look at the infrastructure as a definition at the lower level, it's pretty painful, but it allows you to raise the bar of the abstractions. And perhaps another benefit would be the fact that you can review and test these changes before you merge them. And then so that's where the code review practice finds it really useful. And then it's because it's in the Git repository, the certain operations like rolling back and detecting changes and all that stuff gets really simple and easy. So anyhow, these are just a few of the reasons why this industry is consolidating around the GitOps. But like I mentioned, if you try to build the CI/CD process around Kubernetes by using GitOps, it's as a technologist, it's fun to work on these things, but it's a little bit like opening a bonnet of the car and then try to start tinkering with the engines, right? To deploy the Kubernetes, for example, well, not only you have to install them, but you have to operationalize them. And that's a beast of its own. And then you have to survey the ecosystem of the Kubernetes and try to figure out what kind of tools and services and technologies you need to mesh, stitch together to build a functioning DevOps platform. well, you obviously have to move your application to containers if you haven't done so already. And then how do you deploy, figure out how to deploy containers to Kubernetes. Like, are you going to do the pod file? You're going to do Helm? You're going to do YAML? All sorts of different options. And then, not only stitch up these, a lot of the pieces, but you have to figure out the delivery practice. You have to learn the GitOps. You have to figure out how to deal with secrets. And then even after you did all that, you still wonder whether you did it all right. You clearly put together something that seems to work for you, but you don't know everything. And then so you wonder, well, am I doing it right? Or am I missing out? Did I miss some important things that's happening in the ecosystem? So it's fun to do if you're doing this for hobby, but if you think about what you're trying to ultimately do, which is to develop application productively, it's like you're just trying to drive a car. So at that point, you want to open up your bonnet and fiddle with the engine. So what I think makes more sense is instead of doing all that work, you can just drive the car by picking up something like Jenkins X. And that's really what we built the Jenkins X for, right? The idea is we want to figure out collectively in the community, open source community, the best practices of how to continuously deliver cloud native applications to Kubernetes. And then historically, Jenkins is more focused on running build and test and stuff like that. But in Jenkins X, when I talk about the continuous delivery, I mean the whole thing from code review all the way to the left to more downstream operations, like promoting one version of the app from one environment to another, or dealing with changelogs or collaborations or all the other team dynamics that surrounds the software, right? And then in Jenkins X, we want to integrate best-of-the-breed software that's happening in this rapidly changing ecosystem that is Kubernetes, because we have people who live and breathe this ecosystem to understand what's going on and then spot really useful technologies and then segregate that from things that are very okay. And then we want to hide those complexity of dealing with lots of different technology by abstracting them away behind a convenient command line interface that talks about high-level operations that the developer would actually understand. And behind the scene, we map those to whatever API calls to Kubernetes or other systems so that your people don't have to know about any of that stuff. And then by necessity, in order to do these things, we kind of have to be opinionated about how to do things, right? This is the entire notion is kind of built around the idea that we, the community, can figure out the best way to continuously deliver applications so that you don't have to. And while the stuff that we put together isn't particularly revolutionary or eyebrow-raising, nonetheless, we come with a certain solution that we think is the best for you guys. And then in doing so, I think we can push Kubernetes back to where it's supposed to be, which is a lower-level infrastructure pieces that help you be productive. Just like you don't think about Unicode or JSON when you're building applications, it's just kind of one of the lower-level building block, right? The Kubernetes, I think, should be in the similar space. And then this idea of the being opinionated is kind of new to the Jenkins project. If you've been using Jenkins for long enough, it's kind of in fact, it's the opposite. So historically, in the Jenkins project, I think of it as building a road network, right? In this software development domain is incredibly diverse, and everyone is working on different kind of software at the different, the part of the software development, a DevOps journey. So we let you pick wherever destination you want to go, and often people don't know, right? They start driving, and they kind of figure out where they want to go. And then so every turn, you're in the driver's seat. You can take whatever turns you want. We have 1,600 or so plugins that help you be wherever you want to go. And then it's up to you to drive those. Now, Jenkins X is a little different kind of ideas. It's like building a high-speed rail, I think of it this way. So there's a major metropolis that so many people wants to go, which is the cloud-native web application Kubernetes. So if that's the destination you want to go, you can just show up at the train station, and one of those bullet trains would come onto the platform, and you just need to be on the train. And then we will take you to the destination. You don't need to know where it is. You just need to sit back and relax and enjoy the ride. And then we will take you there in no time without really letting you do any work. So that's the idea. And it's quite complementary in that sense, I think, which makes the Jenkins X rather interesting. Now, I talked about the being opinionated. So the development flow that we preach is kind of like a heart of what Jenkins X does. But at the same time, like as you can see, there's nothing particularly outrageous about it, right? This is something we've been all doing for the past so many years, meaning we have multiple environments that host different applications, like a different progression of the applications. And then in between those different environments, we have, different environments attract on different branches. And then you promote new binary from new bits from one environment to another by merging the branches. So that's the GitOps part. And in addition, as you create the pull request, you get this preview environment, meaning the change that somebody is proposing gets its own copy of the running application. And then Jenkins X kind of stitches together the entire workflow so that you don't have to think about those lower-level details, right? And a little bit more on the best practices that we preach is one, like we think you should be using cloud more for developing software and so that you can keep your laptop for what it needs to be. So, for example, it has this concept of DevPod where you can create your own development environment like on the cloud and then keep that in sync with your laptop so that you don't have to run your entire applications on your laptop, which certainly makes it a whole lot more easier for your laptop. And we also preach, for example, like your master branch should be always releasable. So every change that lands in the master branch, for example, is to get the new versions and so forth, so forth. And then we encourage you to deploy often and in small increments. And then finally, like we think it's a good idea to inform other people around what changes are inbound. So none of these things, again, it's particularly new. Like individually, those are practices that has been making sense forever. Really, the innovation is the fact that these practices have all been combined into one and then behind the functional applications. So that's what I was trying to say. These best practices that in a way it's boring, and in my dictionary that's a good thing. So you don't have to kind of convince people about adopting some outrageous ideas or anything like that. And then behind the scene, like I said, it's using a number of these components. For example, it's got the application called Monocular, which helps you see what are the applications what are microservices in the ecosystem. It's got the Helm. It's got the I forgot the name of it, but the one that received the webhook and then the drive, the Jenkins and other CI/CD services, and then so on and so forth. So this can actually, sorry about that. So and then it supports the multiple different clouds wherever you're using it, and that's an important part of the Kubernetes story. So we got you covered. So what I talked about is a little bit abstract, and there's this notion of best practices and being productive and not tinkering with the engines and so on and so forth. So perhaps the best way to get this idea across, I think, is to let you see exactly like how you can use it and what happens behind the scenes. So imagine if you have a laptop like this one. It doesn't really have any, like a brand new laptop that doesn't really have anything in it. In order to get going with Jenkins X, like first thing you're gonna do is run these 3 commands, right? Like you use a homebrew to install Jenkins X command line, and then you do the JX create cluster. So then it goes through a bit of interactive dialogue to help you decide, where you want to create a new cluster and so on and so forth. But that's it. Now, when you do that, so what happens behind the scene is that you just deployed all the necessary tools on the cloud, properly configured. So it involves things like Jenkins that has the Elastic build agents to build containers, or the artifact repository so that you can speed up your builds, or the Monocular I already talked about. So these are the building blocks that individually combine together to do the work. And then finally, you also get the staging and then production environments already set up, where all your future apps is going to run on these environments, right? So none of these setup, I mean, these are the setup that previously had to be done manually. It's not particularly hard, it's just tedious. It's all taken care of for you just by answering a few questions. So that was the initial installation setup. So let's bring your application on board to Jenkins X. The first you do you have two ways of doing it. Like if you don't have anything, you can create a new project, and then by running JX create. So the third token, Spring, what that's doing is it's specifying a template to create a new application. So in this case, it's like a Java Spring application. So it gives you like initial skeleton source code, whatever Docker file and Jenkins file and some other CI/CD setup that's necessary, and they're ready to go. So it's much easier than like starting from empty, from scratch by yourself. Now, or if you alternatively, if you already have a project, then you can go to its directory and then you can run JX import, and then it basically sucks in those source code and then produce the necessary Docker files and Jenkins files and other surrounding stuff so that it's ready for Jenkins X. So, and then again, like when you run this command, it's so basically just one command, either way it is. You get the source code, or you already have it, and then you get the wiring for the build and deploy and the CI/CD, so that includes stuff that I mentioned. And then it even asks you to, for example, create the GitHub repositories, and if you want to create a GitHub repository, and then it can create those and import those, and then it sets up all the other configuration, like setting up the webhook so that every time new push happens to the repository, then the CI/CD process happens in this Jenkins X. If it's necessary, it's sort of a Jenkins job, all of those stuff. And then as a side effect of that, it creates, it builds a master branch, it creates an initial release, and then it runs that in staging. So all of that setup, again, it's not particularly hard, it's just tedious. Now it's all automated for you just by running that one command. So that's what I mean by being productive. Like you don't have to do this boring, tedious work. So now that you brought your application on board, well, let's work on the change. And this is the part that you repeat the most often, right? And then this really, nothing really changes. You work on the change locally, maybe by using your favorite IDE, and you create a Git commit and push those, and you create a GitHub pull request. And then you have your change review, and then merge with to the master branch, right? That's what you've been doing for years now. What Jenkins X adds to it is all the surrounding automation that's surrounding it, around it. So for one, your pull request gets automatically built and tested without you doing anything. And then once that's built and tested, it gets deployed into what we call the preview environment. So that's a running copy of application specifically to your running PR. So what that allows you to do is when they are trying to review the code change, you don't have to just look at the source code. You can actually interact with the running applications. So if you made a CSS change and the designer wants to see how it's actually happening, they can do that without locally checking out and rebuilding those. And then when you merge your change, and the new master branch, the one that receives the change, also gets automatically built and tested. And then that turns into a new release because we preach this idea that the master branch should be always releasable. There should be a version number to everything that's landing on the release, master branch. And it creates a change log that captures what has changed in this new release. And then that gets deployed to the staging environment. So, and then lastly, so in this case, the promotion to the staging environment is automatic, which can be configured. But let's say, if you're trying to promote the bits to production, then you go to the directory of the applications and you run this JX promote command. So what it specifies is, let's run the 0.0.3 version of this application in the production environment. And then what happens is when you run the command, it creates a pull request on the state repository that captured what version of what applications are running in the production. So remember, it's a GitOps. So when you run this JX promote, it doesn't directly talk to the Kubernetes API to materialize the change. It simply updates the state files, and then that becomes a pull request, right? So then people who have permissions, like say operations team, who needs to approve all the inbound deployment to production, they'd go to GitHub, and when they press the merge, then the corresponding automation kicks in, and then that's the one that talks to the Kubernetes and update the actual the version of the running applications, and then eventually that materializes in production. So, so that's the so this is what it means to be doing doing the GitOps, but it's kind of hidden behind. Well, it's sort of like a lot of the gory details of making GitOps work is kind of taken care of by the Jenkins X. So that's the kind of the flow, the ebbs and flows of the Jenkins X, and hopefully I was able to give you the idea of how it sort of helps you be productive by removing the boring part and helping you focus on higher level abstractions. All right. So that was about the Jenkins X. So let's take a step back and look at the bigger picture of where what we think is CI/CD is going. So first, smaller things out of the way. One of the things, I was feeling this in the Hygieia talk earlier, but there's the demand for the automation is getting bigger and bigger. And then the Jenkins, so as such, it's changing the way people run Jenkins, right? Jenkins X is also pushing it in this directory. So one effort that's going on in Jenkins is try to run Jenkins itself as more like a functional or service style. So the idea is instead of Jenkins being a perpetually running server process, let's turn it into much a shorter living thing. Right? It comes up only for the duration of one build, and it coordinates and executes one build, and it disappears into to the ether. And then they leaving the record behind for the system the Hygieia or whatever for the users to interact with. So it's clear, the benefits that it brings is pretty clear, a better scalability, because, or the better isolation because every build is in the different containers. And then so Jenkins X already uses Jenkins in this manner. But this mode of operation right now kind of comes with various restrictions in order to make it work. So hopefully there's effort going on, as I understand, in the community to try to push this forward. So hopefully it gets better and better and be more applicable to perhaps some of what you're using Jenkins for. So I think the other thing that's now going back to the bigger trend, I think the bigger thing that's going on in my mind is in order to achieve the higher velocity, a GitOps is kind of important as a key developer experience, but that's not enough. And then I think the kind of key change that's happening in the industry that I see is this more holistic approach to the quality. And then that's a key enabler to satisfy the throughput and stability at the same time, the conflict that I talked about earlier. So it used to be that, when it comes to, well, actually, let me step back in this way. So what's taking time, coding up the change is once you type up the change, the reason it takes so much time for the change to propagate to production is not so much because the automation takes time. It's because it takes time for people to build up confidence in the change, right? I mean, that's why you run the code review. That's why you run the test. All of those is to have to build up the confidence that this change is going to actually hold the water in production, as opposed to a blow up and then hurt the credibility of the business. And it used to be that the test is the only thing that stands between those broken code and then the fire in the production. But what's happening, I think, lately is if you only rely on tests, then you can't really go beyond certain speed because you're fundamentally relying on the number of tests and coverages, which is never great enough. So what I think people are doing is to accept the fact that some of the problem is going to slip into production, and then think about other ways to contain the damage or reduce the impact or some other things so that collectively the impact to the end user is small, even if some bad stuff happened in production. And I think this is a key mental shift in order to do the continuous delivery. And I expect this trend to continue. It's a little bit like how the fire safety works in building, right? Obviously, it's better not to cause any fire, but the building like this, they have, let's say, a sprinkler so that if the fire breaks out, they try to contain those. The exit is clearly marked so that the people can evacuate. So all of these things assumes the fact that it accepts the fact that the fire sometimes happens. The same thing is the technology. So let's take the feature flags, right? I'm sure by now you've heard about it. if you think about it, all this, what this is fundamentally trying to do is it lets you deploy code that's not up to the standard of like whatever the team needs it to be, so that you can instantly revert them. You can contain this into smaller corners. The circuit breaker, that's I think the technology that I'm most associated with. Netflix started popularizing this concept. You know, when you have like an interweb of services and like one of them dies in a weird way, like you can create this domino effect that's causing a backup to other services. So the circuit breaker allows you to kill the service cleanly. But again, this is another example of like you accept the fact that some services it's going to die, but even when that one thing dies, like collectively, like the system kind of keeps operating at certain reduced level, and that's acceptable. The canary deployment, I guess another way of saying, okay, I'm deploying a new bits and this might break out. I mean, this might fall, this might blow up. So like, let's try to do this incrementally and like in the smaller, like a batch and so on and so forth. Or the better observability, for example, I was quite shocked, like, so when it comes to better observability, I've been a big fan of the Datadog, and I saw them up there. But anyhow, they've been in the business for like 10 years or so at this point. And I was walking around the show floor in the KubeCon, and I noticed that the whole new generation of the monitoring businesses are cropping up. So I was wondering, wow, there are still more service monitoring companies. Like, what are they up to? And what I learned is like I was talking to one of those signal effects. And I noticed that they recently went into IPO, and I asked them, like, what's the key differentiator you guys have? And they said, oh, like, we can cut down the monitoring, the time it takes to detect a problem from like minutes to seconds. And I was kind of shocked that that was enough to drive IPO. But too, like, it really like, speaks about the sophisticated state of monitoring now, right? In order for, like, if it's taking for you to, say, 30 minutes to detect the changes, to detect the problem to contain the damage, let's say rollback, then shrinking down the 1 minute detection to 5 seconds is not going to do you any good, right? So like the fact that there are so many customers where 1 minute going down to 5 seconds is significant value, they've automated substantially this error recovery process. And that's the kind of thing, again, like, you know, that's the kind of practice that accepts the fact that the shit happens in production. And then like you try to contain the damage, right? So combined, like if you think, I see them all now as a part of the broader QA effort to try to like keep the system functioning while in the presence of problems. And then on this front, the last one that I wanted to mention is this leveraging the production traffic. And I think that's because ultimately there's nothing like production. Like we know that no amount of testing is going to stand it proved its software in the face of the production traffic. So what I noticed that some people are doing is, I was talking to this like Israeli company who do this content recommendation system. So they said every month like they have billions of like the traffic hits. So nowadays when they test a new change, they allow developers to deploy any pull request into production, and they get like a 0.01% of the production traffic routed to it. And then they run for like 2 or 3 hours of that, like experimental bits. And they monitor the same KPI, like a click-through rate or error rate or stuff like that, by using the production monitoring system. So, and at the end of the 3 hours, because like the 0.01% of the billion traffic is still a significant chunk of traffic, they get a pretty good sense of like how stable or like how this new change being proposed is functioning. And then they can use that information to decide whether they merge the change or not. So this is like an ultimate fuck you to the test, right? Like forget testing. Basically, they're saying like, well, I mean, it's not like they don't write the test, but they're not putting, they're saying even if the program like they don't really care if the program is buggy or not. Like so long as it meets the KPI, like so long as it's bringing money to the business, they're okay to ship it basically. So imagine the kind of confidence you can build out of exercise like that, and that's really amazing. So I expect more of these things to continue, and then this is the kind of thing that the people who achieve a certain level of continuous delivery can take on next. So this, I think, is a frontier of the software development. So speaking of a frontier of the software development or the DevOps, once you get into this mindset of more automations, producing more data and using that data to drive decisions more effectively, like this production traffic testing, what I did notice is that some people started to apply machine learning to at this point we are used to seeing the news where the AI is disrupting this and that, and so suddenly the software development, it turned out, was no exception. So this one kind of caught my eyes recently, which is, imagine you're like a DevOps team, a big company, like they have like a 3,000 or 4,000 engineers working on a single code base, which is a pretty massive the code base. So they have everything in the like a mono repository. It's well modularized. It's a big web of dependencies. So they're well organized, but it's just so big. So it takes a lot of time to run the tests to qualify the inbound changes. So the project that they're trying to take on, this DevOps team, was that how can they cut the cost and time of the software delivery process by running these tests more efficiently. So what they did, actually, where they started, is first like a dependency analysis to figure out what exactly needs to be done, right? So imagine these like diamonds are files, and these squares are modules, and the circles are tests. So if you have a static information between dependencies, then you could say, well, if this file has changed, and then the only test that needs, so these guys need to be rebuilt, and then that guy, and then these 4 tests needs to be rerun. But you probably don't need, you don't need to rebuild those or rerun those tests because there's no dependencies. You can statically infer that they are not needed. So you can imagine like at the larger scale, like this would be pretty effective. And then but this is not the great part, because they have already done it before they take on this project. And then what's amazing, the part that's amazing is like the part of this second step project, what they did is they trained a machine learning model to try to predict what tests should run. So this system that they have, because they got so many developers, 10 to the power of 5, so that's like 100,000, order of 100,000 changes goes through this system every month. So they use 1% of that data to train the model to say, it turned out that when you change this file, let's say, that test is more useful, and these tests are really often catching the problem, let's say. Right? So the machine learning model was able to learn those things, and then more intelligently propose the subset of tests to run. So they reported the impact. They said, every time something changes, only 1/3 of the tests are selected compared to the baseline, which is a static inference. And then it's still as effective. So meaning the other thing you need to think about when you reduce the number of tests that you run is, well, you might have incorrectly omit some tests that are actually valuable, right? That should have caught the regressions, and the regression ended up hitting the production. So that would be bad. So they tracked the number, and that was only 0.1%. So basically, it's negligible. And especially if you combine with the fact that, if you mentally picture all the problems, regression that you're introducing in the system by given change, probably the stuff that tests can catch is maybe here, something like that, right? So the 0.1% is just on top of that. So it's basically like a noise at this point. And then by doing this, they were able to cut the cost of AWS execution by half. So that's a significant money saving as well. What makes this amazing is most of us, most of the team that I go see, isn't even doing this kind of a static analysis to speed up the test. They just, every time some changes happen, they run the whole thing. And then, Jenkins projects happen to run the whole thing every time somebody submits a PR. So this big company has been doing this kind of static analysis long time ago, but then they took on this more machine learning-based approach, and they were able to drive a significant improvement to the efficiency and the cost. So that's the kind of thing I think the data is unlocking in the software development process that I think we will see more of. Here's another example where another company has this a big SRE team, big application that consists of like hundreds of microservices that's coming into production. And one SRE team needs to look after all of those. And this place already achieved a very significant continuous delivery. So hundreds of these microservices that's on average deploying once every day. So that's a pretty high frequent deployment. That's faster than many of you. But at that kind of scale, like you can imagine, like SRE team is basically completely overwhelmed, right? They're landing like 400 changes or so production deployment happening every day. So every like a production fire needs to be analyzed, and it's quite painful. So what they are trying to do is, can we estimate the risk of an inbound deployment? Because that is going to help them, prepare accordingly and also simplify the initial troubleshooting sessions. So, guess what? They also deployed the machine learning to this problem. So, they had 1 year worth of deployment history that has like a 40,000 deployment record, of which about 100 of the deployments are failure. And they tried to train the model by looking at attributes like what are the kind of changes, what in the inbound changes tend to correlate with the problematic deployment. So, and then if I understand their impact correctly, it's really staggering. Like they were able to, with the trained model, they'd be able to predict 99% of the production outage with just a 5% false alarm ratio. So this is almost like a perfect prediction. And then I think maybe another thing worth pointing out is like, how many of you have like 40,000 deployment record that we can analyze data, right? It's probably not many companies. Right? So this is, I guess, another example of company already pretty efficient at what they do, being able to get like a leapfrog forward by using those data. They based on these models and algorithms, they were able to learn, for example, that before they deploy the machine learning, they asked the developers to inform the SRE team about the risk of the inbound deployment, and then they are based on this research, they confirmed that developers are useless in estimating their own the risk prediction, which is no surprise. And then the other thing they have found is like when the process is the short-circuited, meaning if the change from the point of change created to deployment is really short, then that's a risky sign. In other words, like if somebody's saying we're going to slap in this change and this is going to be trivial, so check, it's all good, let's proceed in production. Those tend to be a risky one. That is what they find. This is also, again, in some sense, it's not a surprise. And then finally, they also discover that long-maintained code is more risky. So then that's also something we knew instinctively, right? Like if the code has been around for a long time, it gets scarier to change, and so those tend to blow up more often. But what's actually more valuable, what's truly valuable is not about this learning. Like none of these, all of these things we kind of already knew. But what's amazing is now it's not like it's quantified. So I'm making up this number, but when they say long-maintained code is more risky, they could actually quantify this by saying, for example, like every year of the project's life, going to add like a 15% increment to the risk factor. Right? And that kind of number is really can do wonders to mobilize resources to do the right thing. Because when was the last time you said, oh, we need to rewrite this application because it's way too error prone? And then your management says, yeah, that's a great idea, let's do it. It never happens, right? But if you actually put the number, like, hey, this application, because we haven't rewritten it, it's costing the business $1 million a year. That's a totally different conversation. That's a language that everyone would understand. So in some sense, when you try to rely on more data and analyze them, you can sort of stop arguing about certain things, and it becomes more automatic and obvious. And that allows the organization to funnel the resources and energy into the right thing. And then so those things, I think, combined, it's going to make a pretty highly efficient organizations. And then that's something and at that point, I really started thinking, wait a minute, right? Because I used to think, and I'm sure many developers feel the same way, is that the smaller number of the super developers, or the elite developers, can do wonders in ways that army of engineers in a large company can never do. Right? That's the whole idea behind like a startup, for example. But now it seems to me that perhaps the world is heading into a little different direction. All of these samples that I mentioned is around like a large-scale software development getting substantially better by using the fact that they're already large-scale, right? And then, I mean, none of these, I mean, most of the software development team out there cannot justify this kind of like a fun machine learning science project to deploy. Yet when they do, like they brought significant improvements. So the picture I used to have is like a David and Goliath. And then David was the nimble and the more efficient guys, and Goliath was slow-moving organizations. Now the picture I have is some of the Goliath is actually faster than David, and it seems to be unstoppable. So maybe that's kind of a bleak. I don't know how to think about that. I mean, I'm fundamentally a fan of the smaller company and so on and so forth. But perhaps the software development is becoming more like normal manufacturing where scale drives a significant economy. But anyhow, so I'm running out of time. So just to wrap up this presentation, everyone is trying to become better at software delivery. And then, so therefore, they're trying to leverage all these new innovations in the technology like Kubernetes. If you're thinking about doing that, then I think the better thing to think about is the developer experience. That should be the GitOps. And then let tools like Jenkins X drive those productivity gains for you instead of just stitching things together. And the CI/CD, I think, is still evolving. Like there's a broader trend going on, for example, more built around data. And I think it's going to paint an exciting future for us. So with that, thank you very much. And if you have any questions, I'm happy to take.